This is a short video on the complement rule in probability. So the probability of something occurring is equal to 1 minus the probability that it does not occur. In this example here, so if we have two events, two elementary events that could occur, and I'll go ahead and use the example of a coin. So we have a coin and we have the probability of heads and the probability of tails. Imagine this is a fair coin. So if we say that the probability of heads and tails together equals 1, what we're saying is that the probability of flipping a coin and getting either A or B is going to be 1. So that's part of that addition rule, right? So then the probability of A we can look at as probability of A equals 1 minus the probability of B because they're complementary. And you can do this with multiple, you can do this with more than two events. So the probability of A would be 1 minus all other events would be the way to look at that. So for a practice question, if the probability of having test anxiety is 0.35, what is the probability of not having test anxiety? So the way we would set this up, we would say, okay, the probability of A equals the probability of, or not test anxiety. So probability of A, we're setting up as not test anxiety. That's going to equal 1 minus the probability of test anxiety. So not test anxiety is A, and test anxiety is going to be B. So in this case, we just say 1 minus test anxiety, which is 0.35. So the probability of not having test anxiety is the rest of 1, right? It's the remaining probability, so that would be 0.65. Another way to think about this, and one of the other notations that you have in the beginning of your PowerPoint, the probability of not getting A is another way to think about this. So this notation here, you can see is not. So the probability of not A is equal to 1 minus the probability of A. And so it's very similar to that complement. It's just a different way of thinking about it, of that complement rule. So what's happening here is if we say in a psychology study, 60 participants are introverts and 40 are extroverts. So this is the example I used before. What's the probability of randomly selecting someone who is not an introvert? We're actually just getting the complement to introvert, right? That's what we're doing. But we're going to say the probability of not A equals 1 minus the probability of A. So we would say 1 minus A over possible. That's our basic probability of A. And so we would say 1 minus introverts divided by total. And that would get us 1 minus 60 over 100 because there are 60 introverts. And then that would give us 1 minus 0.60 equals 0.40. Now, the other way to think of this is obviously that, oh, well, if they're not an introvert, then they're an extrovert. So I can just say 40 over 100 equals 0.40. And that might work better in your head, and that's totally fine. It's just that if you have multiple different options, like in this example, if I want to say not A, I can do two different things. So I can say, okay, if we're saying that it's not A, so I'm saying not A, right? I can either add all these together. And if you need a refresher on why we can add these together, I would go back to the addition rule video. But I can either add all these together and I'll get the total that are not A. But the easier way mathematically is to say, okay, well, it's just 1 minus the probability of A. And so I can say 1 minus the probability of A is right here, 0.17. And so that's going to equal 0.83. Or about 83% of die rolls would be not A based on probability. Long-term probability is what we're talking about because, again, this is the frequentist approach to probability. So you can do it either way. It's just a way of thinking about it. I just want you thinking about what probability means so that when we're talking about the normal distribution and talking about sampling, that these ideas make sense as we talk about them. So again, there's practice activities for you after this video. And then just let me know if you have any questions.